All right, boys and girls, welcome back to the drive-through, brought to you by 7th Bell Study Hall. Interested in Advanced Study Hall? Stop by 7th Bell Study Hall and check it out. And play Would You Rather, part of the curriculum. All right, so this is 10-7. This is pretty quick, so this should be a quick lesson with one example. You already are hopefully comfortable with these words, even though the one will make you giggle. So a polygon is said to be inscribed in a circle. You already learned that one. If all the vertices of that polygon lie on that circle. So that pentagon is inscribed in the circle. A polygon is said to be circumscribed about a circle if each of its sides are tangent to the circle. So tangent, tangent, There, this quadrilateral would be circumscribed about the circle, okay? The center of this thing is referred, the center of that circle is referred to as the circumcenter, which is quite confusing, but let me try to explain that. Why? Okay, this circle is what we're really focused on. And this circle is circumscribed about the polygon. So the thing is, these words can kind of be switched if you switch the object of the sentence, if you will. So this circle is circumscribed about this polygon, and that makes this a circumcenter. And this circle is inscribed in the polygon, and that makes that the incenter. However, my notes are not wrong, because if you read the notes carefully, this polygon is inscribed in the circle, and this polygon is circumscribed about the circle. So that can be confusing. All right, you got two theorems for today. The first one I think you should have understood by doing today's warm-up question. So if a quadrilateral is inscribed in a circle, then the opposite angles must be supplementary. So let me get a really good circle here so you guys can believe this. And we'll use the line feature here. Let's do just a really funky quad. All right, so we got a quadrilateral. Notice that the quadrilateral has 4 vertices. We are talking about opposite angles, okay? So this angle here would be half of this blue arc, and this angle here, this obtuse angle, would be half of this pink arc. But notice that the blue arc and the pink arc form a complete circle, and they always will in a circle if they're across from each other. And that is why we know that this plus that, or this plus that equals 180. Okay? Well, with that fact in mind, if you've got a parallelogram that has been inscribed into a circle, well, then you know that its opposite sides are supplementary. Its opposite angles are supplementary. However, its opposite angles are congruent. And we should know that if angles are both supplementary and congruent, then they are right angles. These angles are supplementary and congruent, and they are right angles, and that's why that is a rectangle. All right, so let's just do one quick example with this. All right. A rhombus whose sides are 3 inches is inscribed in a circle. Find the area of the circle. Okay. Well, look, this problem goes right along with that fact we just learned. if the rhombus is inscribed in the circle, then what must be true about its angles? Well, hold on. There's no way I can inscribe a rhombus in a circle unless its opposite angles are supplementary, but in a rhombus, the opposite angles are congruent, so that makes this a rectangle, but it's not just a rectangle because it's a rhombus. Aha, it's a square. Okay, so we know we've got 3, 3, 3, 3. We're looking for the area of the circle. This is a 45, 45, 90 triangle, so that is 3 radical 2. And then our radius is 3 radical 2 over 2. So our area will be, let's see, pi times 3 radical 2 over 2 squared. Let's write that out and help you guys simplify this. Alright, so the pi is just there for now. This fraction is going to be over 4. And you kind of treat this like 3x times 3x. So that is 9x squared. So that's going to be 9 times radical 2 squared, which is 2. Okay? So the answer is 18 pi over 4, or 9 pi over 2 is our answer. Can I get a boom, Ryan?